Hey everybody, welcome back. How's it going? So last time we made one function, which was y hat is beta and x, and it's really just beta dot x instead of doing, beta naught plus beta 1 times x explicitly. We can just write that, and more generally, with numpy vectors or arrays, as the numpy dot dot between the beta vector and the x vector. Okay, so that's really awesome if we want one prediction. Except think about how would you actually use this if you want multiple predictions? Well, the thought that comes to mind is for I in range n, get prediction for each x vector. So we'd say, get prediction for the first x vector and the second one and the third one. That's a for loop, which still sucks, and so we'd be using we're not using a vectorized approach there. So to do this vectorized, it's very, very similar, except it goes back to our idea that we derived before, is we need to use our design matrix. And so that would be done right here, where if you recall, we have, let me just point at stuff. So the design matrix is simply each row is our information of people or data points, where the first thing is 1 because that simplifies it for us. So if we arrange those, this is the first person and this is the second person, then we can get the prediction vectors where each component of it is just that person's prediction, the prediction we have for them. Well, that's simply x beta. And that mathematically is written out more formally like this, but all it's doing in NumPy, if we were to write this in NumPy, is NumPy dot dot of x and beta. X is going to be, a matrix like we saw before, and beta, well, we'll see what shape actually works for beta since it's kind of weird with vectors. So now in the code, we're going to think of x as a matrix. We're going to force it to be a matrix. So we're going to change that to an uppercase in both spots. And so uppercase x is a NumPy array of shape n by p. Okay, it's an n by p matrix. And with this equal to 0. That's saying all of the rows and the first column. Remember, that's how we get the first column. So I'm just specifying here that the first column is entirely 1s because that's how we arrange our vectors. That's how it's going to work out. Okay, so then beta is shape p comma, and that's actually going to work out to be fine. We'll see that. And the only difference here is that we choose x and then beta. So then you can picture it as, you have your square thing on the left and then your column on the right. And yes, I know, is it really a column vector? Kind of, sort of. It's a list of information, so it's going to work, trust me. So if we were to test this out, we would have beta is this vector. That's totally fine. We're not doing anything to beta. But then I'll say x, capital X, is equal to, so maybe that was the first piece of information. And then the second piece of information is say 1, 2, 3. Okay, that's the same as the other thing. So let's change that a little bit. 1, 5, and then 1. Okay, so first piece of information, second piece of information, we want a prediction for this one, which is just this dot product with that, and we want this, a prediction for this, which is just this dot product with that, and that's exactly what this matrix multiplication, or matrix vector multiplication, or numpy dot dot is going to do, is if I call this with beta and x, then it gives invalid syntax because I forgot a square bracket here. And that's going to happen a lot. And then this turns out to be 2414, which notice its shape is it's just giving us back this kind of vector-like thing. I'm going to keep saying that. I'm probably just going to start calling it a vector. And so just to check its math here, so what we have is, I'll write it in red, is we had the matrix of 1, 4, 5, 1, 5, 1. We had the vector of 1, 2, 3, 1, 2, 3, and that is going to be equal to, if we dot product this with this, we'll get 1 times 1 is 1, 2 times 4 is 8, 3 times 5 is 15, so that's 15, 23, 24, just like it said, and then 14 is 1 times 1 is 1, 2 times 5 is 10, so that's 11, and then plus 3 times 1 is going to be 14 in total. Okay, so it was correct. That's what the result gave. And now it's really truly vectorized, where if you want all of our predictions, you can just do it with this operation right here. And notice it didn't even get any more complicated. So it's pretty awesome. And I'll see you in the next video where we do, again, simplify stuff and make it really easy.